One of the methods for traversing a binary tree is to use an in-order traversal. At each node in the tree, starting from the root, we begin by traversing the left subtree if it exists, then visiting the root, and then traversing the right subtree. Starting from the root right here, we follow step 1 and go to the left. When we reach the next node, we use the algorithm again and take the left subtree again. At this point, we realize that there is no left subtree, so we can move on to step 2, which is visiting the root. A is the first value which we have visited. This node does not have a right subtree either, so we have finished the algorithm here and can work our way back up the tree. At this point, we've traversed the left subtree, so now we're on to step 2. We want to visit the root. Then we can move on to step 3 and traverse the right subtree. This node, like the one over here, does not have a left or right subtree. So we can cross out step 1, visit the root, cross out step 3, and then work our way back up the tree. Now at this point we've completed all 3 steps, so we can keep going. Here we are now on step 2, visiting the root. And now we go to step 3, traversing the right subtree. This process continues at each of the nodes until we've worked our way through the entire tree. It is not required that the tree is a full binary tree as shown here. Once we reach the original root, we have finished traversing the tree. When in-order traversal is used with a binary search tree, where each left child is less than the root, and each right child is greater than the root, such as the one here, the traversal will display the keys in order from least to greatest. Another way to traverse a tree is to use preorder traversal. Unlike in-order traversal, preorder traversal does not have to be used on a binary tree, as the number of children does not make a difference. To use preorder traversal, you will first visit the root. You will then traverse any subtrees, starting from the left and working your way right. Here we start at the root and get its value. Then we move on to step 2 and traverse the left subtree. Again, at this point, visit the root, traverse the left subtree. When we get down to a leaf, it does not have a left or right subtree, so we can just work our way back up the tree. When we get up to here, we're on step 3, so we now traverse the right subtree. This is also a leaf, so like A, it will not have any children. We can work our way back up, and we will get all the way back up to the root. We can now traverse the right subtree. This continues until every node of the tree has been visited. Once we have completed all 3 steps on the original node, then we are finished. One use of a preorder traversal is to print out a bulleted list. At each level, we will output an additional tab as well as a bullet point. Starting from the first level, we do not output anything other than the text. We then traverse the left subtree. Since we have now gone down a level, we will output a tab and a bullet point, then the text of this node. Traverse the first subtree starting from the left. We output an additional tab and then a bullet point, then the text. This node does not have any children, so we can work our way back up the tree and move on to the next child. Again, we are at the second level, so we output 2 tabs and then the text. And we keep doing this until we've made our way through the entire tree. Here we're back at level 1, so we only output 1 tab. Down to level 2, and then back up. Once we reach the original root node, we're done. Postorder traversal is another common way to traverse a tree. It is similar to preorder traversal, however you will traverse the subtrees first, and then you will visit the root. In the case of a binary tree, you will traverse the left subtree, then the right subtree, and then you will visit the root. In this example here, we start, traverse the left again. This has no left, it has no right, so we visit the root. We can go back up, then traverse the right. Again, has no left, has no right, so we visit the root. Work our way back up, and we can finally visit the root here. Go back up again. We can't visit the root yet, we must traverse the right subtree still. Traverse the right, traverse the left, no right, could visit the root. Go back up, traverse the right, no left, no right. Again, this will complete once you've reached the original root. One use for postorder traversal is to solve arithmetic expressions. This tree right here represents this arithmetic expression. The internal nodes are the operators, the external nodes are the operands. At each node in the tree, before we can perform the arithmetic expression, we need to know what the value of the left subtree is and what the value of the right subtree is. So starting here, to determine the value of the left subtree, we go down to this node here. Again, we need to know the value of the left and the right. So moving to the left first, we know the value of the left, it's 8, and we know the value of the right, so we can perform this expression right here, 8 minus 2, which will be 6. So we can replace this right here with the value 6. So now this is our new expression. Now moving back up to this node, we know what the value of the left subtree is, and we know what the value of the right subtree is. So we can add 6 plus 4, and we can get a value of 10 for this node. We have our new expression, and we can replace this with 10. So now at this node, we know what the value of the left subtree is, but we still need the value of the right subtree before we can complete this. So moving down to the right, we have the value of the left, and we have the value of the right, so 6 divided by 3 will be 2. We can finally perform this operation. We have 10 times 2, which will be 20. So we used a postorder traversal to evaluate this expression to 20. In-order is only used on binary trees and is accomplished by traversing the left subtree first, then visiting the root, and then traversing the right subtree. It will give us an ordering like this. Preorder traversal can be used on a tree with any number of children. You start by visiting the root, and then you traverse each of the subtrees starting from the left and working your way right. Preorder will give us an ordering like this. Postorder, like preorder, can be used on a tree with any number of children. You should start by traversing the subtrees, beginning with the left and working your way right. After traversing all the subtrees, then you can visit the root. This is the order given by a postorder traversal.